Hey everyone, welcome back to virtual Azure Community Day. Small switcheroo of hosts. Hi, I'm Mark Duiker. Suzanne has now a well-deserved break. We still have like 5 sessions for you. That's quite a lot. First, one longer session, and then 4 shorter sessions. So we're gonna start about with Erwin. Hi, welcome.
Thanks, Mark. Happy to be here.
Great. So what have you been up to lately?
Well, in the beginning of the new year, I've started to do a few of these sessions again. So this time remote, and there's also another session coming up in real life. So that's always nice after the whole Corona period, in which we had to do it all virtual.
Yeah.
So I'm really glad that that's all starting up again. Yeah.
That's great. Yeah. So how's work at Experience? Because we were like very briefly colleagues at Experience, but like maybe for a couple of days only, and, then I left.
When I came in, you left like 2 days ago.
Bad timing.
I thought it was me, but
no, definitely not.
Yeah, that's all fine. Doing nice assignments with our clients, doing all cool stuff on the Azure cloud. So yeah, it's all perfect there.
I'll give them my regards next time you see them.
I will.
All right. So I would say, get ready for your next session, all about networking. It's very nicely ties in with all kinds of other sessions we have just seen.
Yeah.
And also personally for me, I'm going to learn a lot because it's really one of my weaker points, networking and security. So I think I'm going to learn a lot.
All right,
so
cool.
Feel free to take the stage.
All right, thank you.
All right, and yeah, while Erwin is preparing his slides and the session, I mean, will there be some demos as well?
Yeah, lots of demos.
Oh,
yeah,
excellent. Okay,
I'll be switching all the time.
Oh, excellent. Yeah, okay. I love some live demos. Although we've also seen that these things can go wrong when you're doing them live. But yeah, I'll be praying to the demo gods that all goes well. All right, I think we're almost ready to go. Good luck.
All right, thank you, Mark. And once again, welcome. Thanks for joining me in this session. And we're going to talk for the next 50 minutes or so about networking on the Azure platform. And mostly about networking on the platform as a services on Azure. How do you use networking to protect key vault, SQL databases, storage accounts, and all those kind of things? So before we dive into the details of it, my name is Erwin Staal. Like Mark mentioned, I work at a company called Experience in Hilversum, which is not too far from the studio today. But I actually live in a town called Assen, which is up in the north of the Netherlands. And I'm an Azure architect and a DevOps consultant for Experience, helping our clients with all things in the Azure cloud, amongst networking. So in the Corona pandemic time, when we couldn't do public speaking, etc., I decided to write a book with also Eduard Kelhorst, who did a session this morning, and Henry Bain. We decided to write a book on Azure infrastructure, and especially using Azure infrastructure with Bicep. If you want to know more about that subject, then this book might be for you. All right, let's dive into the subject of networking. The first time that I worked for a client and actually had to do something with networking was when I worked for a company that was building a SaaS product. They were building a business-to-business e-commerce platform, and they wanted to allow their customers to use their credit cards to do payments. And when you want to support credit card payments, then you also need to comply with one of these standards out there, which is called the Payment Card Industry Data Security Standard. And this nice little graph that you see here on the screen is actually a diagram that I grabbed from the documentation by Microsoft, in which they explain how to actually implement a design, a network architecture design that will comply with the particular standard, and they actually have blueprints and whatever, so you can easily deploy that and see how that goes. And what we see in here is that there's multiple layers of defense in place between the actual user coming from the internet and your crown jewels on the right, being your storage or your SQL or maybe your secrets in a key vault. And there's all sorts of layers in place in terms of networking to ensure protection between the public internet and the stuff in the backend. And in the session today, we're going to see a lot of those services in Azure in place and being used to build something similar like this, but then in a bit of an easier smaller example. So the demo I'm going to build up today uses the architecture that we see here. So what we're going to do is that we're going to use a SQL database, which obviously stores a bit of data. And that's being read by an API, which runs on Azure, on an Azure App Service. And what we want to do is that we want to ensure that just that Azure App Service, the API, can actually access that SQL database, but no one else can, at least not from the public internet. We want to shut down the public access to the database. And then we will host another application, our front-end application, which also runs on an Azure web app. And we want to ensure that that front-end application is actually the only application that is allowed to connect into the API. What's important to note here is that the application, the front-end application running there on the app service is a server-side application. Shutting your API down from the internet obviously doesn't work if you have a front-end application running in the browser of your users. So this is a front-end application running inside of an Azure App Service. And we're going to see how we can ensure that just that app service can actually connect into our API. And we're going to use different services to get that to work. But you might be wondering now, if you shut down your API from the public internet and you also shut down your database from the public internet, then how do I still get into that as an engineer to do deployments, but also do migrations and updates in the database? So there's various ways to still be able to get into those resources over private networking. And we're going to talk about a few of those solutions today as well, which will involve, for example, a VPN connection, DNS, etc. So this is the whole flow that hopefully will work at the end of this session. All right, networking obviously all starts with a network. So the first thing that we need to do is actually create a network in the public cloud. And in Azure, that's called a virtual network. And a virtual network allows you to have your resources in the cloud talk to each other over a private connection, using a private IP address. So what you can do, you can create a private network. And within such a private network, a VNet, you can create subnets. So we have a virtual network, which we can divide into smaller groups, which we then call subnets. And when you create a network and when you create these subnets, you need to think about the IP addresses that you want to use within those networks. And as we see on the screen here, there's a few IP ranges that you get to pick from when you decide on which IP ranges you want to use. Those are all the private IP address ranges that we agreed upon to only use for private use and not on the public internet. So depending on your need and basically depending on the amount of IP addresses that you need, you can pick either one of these three ranges and then use those as your IP range. And when you start setting up your network, you need to think about how many IP addresses do I need now, but also in the future, so you can create your network having the right amount of IP addresses. Not too much, not too little. You can change the amount of IP addresses in a virtual network, but it becomes a lot harder when it's actually in use and IP addresses are in use, etc. And it becomes a lot harder to move around and make things grow. So you need to think about the number of addresses you need upfront and do proper design. What's important to note also here is that when you create a subnet in Azure, then Azure needs from that subnet at least 5 IP addresses for its own use. So it needs an IP address to do some DNS assignments, etc. It needs a broadcast address, etc. So that means that if you create a subnet, which would normally have 64 IP addresses, you now end up with 59 because Azure needs 5 of its own. So you also need to take that into account when you design for your network space. Another thing that you can do with networks is actually couple them together. So imagine you have 2 networks. You could actually create a connection between those 2 networks, which we call a VNet peering. And that would allow you to connect into resources from one network into the other. So that might be useful, for example, if you have multiple teams, they can then own their own network. But if they still need to connect into each other over a private level, then you could create a VNet peering between those 2 networks, which would allow those 2 teams to connect to each other over a private backbone. There's two types of VNet peering in the Azure cloud. There's the virtual one, the virtual network peering, and there's also the global virtual network peering, which, as the name implies, would be used when you do global stuff across regions, where the normal peering is used if you just stay within the same region. To do global VNet peering, there's a cost aspect involved, obviously. You need to cross regions. All right, so let's move into the first part of this demo, which is that we actually need to create a virtual network to start with. Let's head over to the Azure cloud and not nu.nl. And let's see what a virtual network in the Azure cloud actually looks like. So I've already been upfront creating a few resources, which we can use during this demo. So if I scroll down, and you see already a SQL-server, there's already things like application insights, there's the app service plans, etc. And last but not least, there's also two virtual networks that are already created. So let's open up one, and let's see what we can actually configure on a VNet and what it actually looks like. So probably the most important thing on a network is its address space, which defines which IP addresses you actually use within that particular network. And here you can see that I picked this particular range, which gives me 256 IP addresses. Then, within that global range on the virtual network, I can create these smaller groups called subnets, of which you see two in this particular example. And those also have their own IP range, which obviously has to be smaller than the range of the whole VNet, because they have to fit within the global VNet range. So you can see that these two VNets actually have less IP addresses available, obviously, than the 256 that we saw before. All right, so there's a lot of other stuff that we can actually configure on a VNet. Most of it goes beyond the scope of the session today. One thing that I do want to touch upon is DNS. The service, obviously, that does the resolving of IP addresses by domain names. And by default, you can just use the one that Azure provides you. But later on in this session, we will see that in some cases you actually need to configure your own for good reasons. But we'll get to that in a bit. All right, before I get back to my slides to introduce the next step, let's very quickly have a look at the applications that I've built. They both are very simple, just for the purpose of this demo. This is the UI that we will use, a .NET Core MVC application running on an app service. And there's obviously also an API that just returns a bunch of data in a JSON format. Nothing special, nothing fancy. All right. So the first thing that we want to do here, we're going to start, if we look at this demo architecture, we're going to start with the database, lock it down, and then move our way to the left and move and go on from there. So the first thing that we're going to do is lock down that database to ensure that no one over the public internet can access it, and only our API will be able to get into the database. And we are going to do that by use of a private endpoint. And a private endpoint is a service in the Azure cloud that allows you to reach a PaaS offering, a platform as a service offering in the cloud, over a private IP address. So it means that I can now go to my database, to my key vault, to my storage account over a private IP instead of over the public internet. And for most of the resources in Azure that you can use a private endpoint with, you can choose if you want to only enable access over the private endpoint, or that users can also simultaneously still connect it over the public internet. That's a choice that you can make. The benefit of a private endpoint is that the traffic obviously stays within the Microsoft network. So it's secure, it's faster, and it's more reliable. Another benefit is that private endpoints can also perfectly be used over a peered network, so from another network, and they also perfectly work from on-premise environment. So you could have a database in the cloud that you reach from on-premise over your VPN connection, for example. That all perfectly works and is often used in migration scenarios. So the private endpoint can be used on a lot of services in Azure, as we can see in this list. All right. So we're going to now focus on this particular part of the demo, let's add a private endpoint to that SQL database to make sure that it's locked down from the internet. We're gonna go to my SQL server, and we're gonna go to the networking blade of that SQL server. And do note that I'm going to the SQL server and not to a particular database. So it means that any database that we host on this particular server can be accessed over this particular private endpoint. So I obviously have to give that thing a name. And we're gonna say that we want to have this thing in Western Europe, because that's where I run all the stuff. You hit next. And then you get to pick the target sub-resource for your private endpoint. Where is your private endpoint gonna point to? And since I came from the SQL Server blade, it's obviously gonna be SQL Server. Then it will ask me which virtual network I want to use, in which network and which subnet should this private endpoint get its IP address. So I'm gonna use the API network, and I'm gonna put it in the subnet, which is called default. Then we can continue and go to DNS, and it will now ask me if I want to integrate with what we call Azure Private DNS, a private DNS zone. And you can imagine that now that I lock down this database from the internet, I also cannot use any public DNS anymore to access this particular server. But you still want to be able to use DNS and not connect over a IP address, right? IP addresses might change, and you don't want it. So it asks me if I want to integrate with a private DNS zone, so I can actually still use DNS while using private addresses. And I obviously want that. All right, let's hit next, and let's hit create. All right, so this deployment might take a while. So we're gonna come back to this in a bit to see what was actually the result here. But this is actually the first step that you need to take if you want to lock down your SQL server. The second one is to go back to the networking blade of the SQL server, and then on the public access page of it, say that you want to disable the public network access. Because by doing that, we also disable this particular checkbox down here at the screen. And this checkbox is what normally allows your app service to just connect into your SQL database, because you've just allowed all resources in all Azure environments, not just your subscriptions, but all Azure resources. And we obviously no longer want that. So we're gonna hit disable here, and we hit save. And that's right in time, because also the other deployment was done, apparently. So my private endpoint was created, so I can actually go into the private endpoint. And one of the interesting things here is that I can also go into the DNS configuration for that private endpoint, and I can now see that there is a DNS name actually pointing to my private IP address. And that's important, because then that means that if you switch from using the public connection to a private connection on a SQL database, or on a storage account for that matter, or on a key vault, you don't actually have to change any connection. Your application, your web application, will just continue to run, because it can still use your default connection string like you were used to. You don't have to change that. You can just use the original one that you were used to. All right. Well, with that being in place, if I now go back to my API and I refresh that, it might sometimes take a while. I might need to come back to here later on. But this should actually now, in a bit, give me an error telling me that I'm no longer allowed to get into the database over the public connection. But like I said, it might take a while for the firewall changes to kick in. So let's go back here in a bit. Because what we've done now is ensure that our database is locked down from the public internet. So the next thing that we want to do is ensure that the app service that we use, our API, is still able to connect into the database. And we're going to use a technique called the app service VNet integration to do that. And with the app service VNet integration, what you basically do is you give a subnet to your app service, and your app service will then run from in that subnet. And all its outgoing traffic will then flow through that subnet into any resource you try to connect into. That's an important distinction to make. It's only for outgoing traffic, only for the type of traffic that we try to use today here. There's two flavors of VNet integration. There's again a regional one, just like we saw with the VNet peering, and there's a global one, which allows you to connect into subnets and regions, subnets in other regions than the one your app service actually runs into. So the last benefit that you actually get from putting your app service in a subnet is that subnets can have something we call a network security group, which is basically a list of allow or deny list of traffic you want to allow in or out of that subnet. And since my traffic now goes through my subnet, which can have this allow or deny list, I can also deny a lot of traffic going to the public internet, for example, that I no longer want to allow out of my application to prevent data being exfiltrated onto the public internet by a faulty package, for example. All right, let's see what that looks like in the Azure portal if we want to enable that on the app server. Let's go back to the API, to the app service of the API. If I go to the networking blade of that, then we will see all sorts of features here on the Azure app service, and today we will see a few of them. The one that we use now is called the VNet integration. So let's go in there, and then we can say add VNet, and I get to pick a network that I wanna use, and I get to pick a subnet. And now there's something interesting going on here. You see that my VNet actually has two subnets. It has the default one, and it has the app service subnet. But you already see that I'm no longer allowed to use the default network, which we just used 5 minutes ago for the private endpoint of the SQL database. And that is because the Azure App Service wants a VNet for its own, because what actually happens is that you delegate this particular subnet to the Azure App Service. So you give it to the Azure App Service, and the Azure App Service is then the only thing that can actually run in that particular VNet. So when you design your network, you also need to think of these scenarios. You need to create a separate subnet for an app service because it simply needs one. And there's different services in Azure that also have this sort of limitation that they do require a subnet of their own. So you need to think of those scenarios up front as well. All right, let's pick the app service, and let's add it to the VNet. Let's also see quickly in between if this actually gives an error. Might be that quick. That was too late already. All right, let's see if this actually worked by going into the console of the Azure App Service, run a particular query, and see if the address that I get back from this particular command actually is the private address instead of the public one. And it is not. This also, again, might take a little bit of time or actually get stuck. Let's do it again. It sometimes takes a bit of time before these networking changes kick in and actually do come into effect. No, still the public one. All right. We are going to move on to the next section of the demo. And we'll do this again when we get back into the Azure portal to see if it then actually does work. All right. So the next thing that we want to do is move on in our architecture and ensure that the UI that we have, the front-end application, is the only application that's allowed to access our API. I could have used, again, a private endpoint. Put that front-end application of us in a network and use a private endpoint towards it, towards the API, and use that for its communication. But there's also another service in Azure that we can use in these type of scenarios, and that's called a service endpoint. So a service endpoint basically provides a secure and direct connection to a service in Azure. So in the example that we see here in the image, on the left we have a virtual machine which runs in a VNet, or in a subnet in a VNet, I should say. And it tries to connect into an Azure SQL data warehouse. And it doesn't do that over the public internet. No, it doesn't do that over a service endpoint. And what's important to note here is that the SQL data warehouse itself isn't in a network. It's not in the same network as the virtual machine is. It's now using the service endpoint to connect into that SQL database warehouse. And that works because on the subnet in which that VM lives, we have said that we want to use the service endpoint towards that SQL data warehouse. And what then actually happens under the hood is that in the virtual machine now knows of a better, more optimal route into the SQL data warehouse instead of going over the public internet. So that's a different way to connect into services in Azure. And then the benefit of using a service endpoint, apart from a more optimal connection, a more optimal route, and staying within the Microsoft backbone, is now that the service I'm trying to connect into, I can restrict access to. So on the SQL data warehouse, I can now say, I only want to allow traffic from that particular subnet to be allowed. Although that SQL data warehouse isn't in that same network or isn't in a network at all, because the traffic is coming over a private endpoint into that SQL data warehouse, I can limit traffic just to that particular subnet. And that's exactly what we need in the particular, in our scenario today. So we're going to see that in a bit. So service endpoints can be used on quite a few services in Azure as well. The list isn't as large as for the private endpoint, but it's still quite a lot of services that you can connect into in the cloud over a service endpoint. All right, so let's see if we can now fix the first part, and that is ensuring that the traffic from my app service, from my front end, actually goes over a service endpoint into my API. All right, we do that by going to our UI, and again, we need to put a UI into a VNet. We're going to use VNet integration again, which I've already done, because it sometimes takes a while to come into effect, as we've seen on the API. So I've already done this one up front. If we click on that, then we get a bit of details on the network that I've used. It's a different network than the API. It's also a different subnet. And the enabling of the service endpoint is something you actually do on a subnet, which is right down here. And as you can see, I've already enabled that for Microsoft.web, which is the app services in Azure. And as you can see, there's quite a list of things that I can also use service endpoints to connect into these type of services. So what this will do, under the hood, the app service now knows of a better, more optimal route into the Azure app services instead of going over the public internet. And the enablement of a service endpoint can take up to 15 minutes. That's also why I did it up front instead of here live, because that would just not have worked. So it might take a while to kick into effect. All right, so that is then just half of the solution. We've now ensured that the front-end application uses a service endpoint to connect into my API. But my API still allows access from everywhere around the globe. So let's fix that part. And on an app service, they've called that access restrictions. And access restrictions are basically just a list, a priority ordered allow deny list that controls the network access to your application. So you can say that you want to allow access from a particular IP address, or want to allow access from a particular virtual network, which is what we're going to use today. Or you can actually also use what we call a service tag. And a service tag in Azure is actually a list, a combination of IP addresses being used by a service in Azure. So you could say, I want to allow all Azure App Services to get into my application using a service tag, for example. But we obviously today want to just allow our front-end application to be able to get in. Let's go back into the portal. Let's go back to my API. Let's again go to the networking blade. And we now need this feature on top here, which is called the access restrictions. And if we scroll down a bit, then this is the place where we can add these allow deny rules. So let's call it UI. I need to give that a priority. And this is where I get to pick the type of traffic that I want to block or allow. And this time I want to use a virtual network. So again, I need to select the network. I'm going to select the UI because I want to allow traffic from it. And it already selected the app service subnet in which my front-end application lives. I can be a bit more specific in terms of HTTP headers and filtering, etc. That the application should send along, but today we're not going to do that. So I'm going to add this particular network rule, and I'm going to hit save. And it's going to warn me for the fact that if I do this, it's also then directly going to block public access to my application. And what we'll see in a bit is that now that I added my custom rule, the service itself changed its default rule into a deny. So only traffic coming from this particular subnet is now allowed, the rest is being blocked. So if I now go into here, you now see a forbidden, because I'm no longer allowed to go in. If I try to refresh my UI, then this one should actually still work, although it does take a bit of time. Which also might be because, again, kicking in networking rules takes a while. All right, while that's spinning, let me explain another thing here. You might have noticed that I've now changed this particular rule on the main side of my Azure App Service, which is the thing that your users actually access when they go to your app service. But an Azure App Service also has an advanced tool site. It's another URL that you can log into and look behind the scenes of your Azure App Service. See which files are stored, go through a bit of logs, use PowerShell to run a few commands, etc. So there's a service behind it that you can go into to do a bit of debugging, etc. And as you can see, that site also has its own set of rules. So you can also block the admin panel to say you only want to allow traffic to the admin panel coming from your office IP address, for example. Or if you use VPN connections, only allow the connections to come over a VPN address instead of allowing the public internet to go there. And you can also say that you want to have the list exactly identical to the public one. That's also an option. All right. This one's now giving an internal server error, which is not exactly what we want. It's always the demos, right? All right, let's see where I'm at. Let's do a quick scan.
I'm not sure I understand.
Siri is not going to help out here today. All right, let me quickly go over a bit of configuration to see if this actually is correct. This kind of looks correct. This seems to be okay. Let's head back to my API. I've had in the past that I've injected the app service into a VNet, and then they hit save, and it said okay, and it actually wasn't okay. So let's see if that's the case here today. It doesn't look like it. Let's see if this is all looking fine. It's in the API network, it's in the app service subnet. All right, that all looks good. This one actually does say forbidden, which is also good. For some reason, today this doesn't work. All right, in terms of time, we're gonna continue. All right. So what should have worked by now is that we have a SQL database that's only, and you actually saw that part kind of working, only accessible from our API. And the API, as you've seen by the 403 forbidden, should now only be accessible by my front-end application. You might be wondering, now that we've seen the private endpoint and the service endpoint in action, which are two services that can be used in some scenarios for the same purpose, what is actually the difference between the two, and when do you actually want to use what? So I created a little list to go over that. So what's important to note is that when you use a private endpoint, you actually create a connection onto a private IP address to just your instance of that platform as a service offering. So it's a private IP address into your SQL database, whereas a service endpoint is a route to the whole of the SQL-server PaaS offering in Azure, not just your instance, but just a more optimal route into all the servers in Azure. So a private endpoint is used to go to a particular instance of yours, whereas the service endpoint will send traffic from your VNet to the platform as a service offering. A private endpoint can be used within Azure, but also from on-prem into Azure. Like I mentioned, you could connect to a database in the Azure cloud through a VPN connection. But a service endpoint is only usable from within Azure, only from VMs or app services, etc., within Azure into other services in Azure. A private endpoint is also a bit more difficult to set up. There's a lot of more stuff involved, like DNS, etc. And what you especially see in larger environments is that you often don't get to manage the private DNS zones, for example. But when you do create a SQL database and add a private endpoint to it, you do want the DNS to be registered somewhere. So you need to put a bit of automation in place to get that to work. Or you need to get permissions on the private DNS zone that you might not own. So it's a bit more difficult to set up than, like you've also seen, the service endpoints, which is just basically a checkbox on your subnet. And you don't need to own the service on the other side. You don't need to own DNS, etc. That's a bit easier. But for both goes, the traffic remains on the Microsoft backbone. And so for both goes that you get a more optimal, more performant route into the service you want to connect. All right. One other feature, networking feature, that I want to tell you about today is the use of the NAT gateway in Azure. So imagine the situation that you have an Azure App Service and that you connect from your Azure App Service into a third-party service, like a payment provider or something. What you then quite often want to do is give that payment provider a list of your IP addresses and make sure that only you are allowed to connect into that particular service. But if you ever looked at an Azure App Service and tried to figure out the IP addresses that an Azure App Service can use to connect into some other service, that's quite a huge list of IP addresses. And those IP addresses are not just used by your app service. Those IP addresses are also used by Azure App Services of other clients. So by giving that list to a third party, you have allowed your application, but also potential applications from others. And that might not be what you want to do. So luckily, there's a service in Azure that you can now use to route your traffic over to the public internet to ensure that you always have a static outbound IP address that is just used by you. And one benefit that you also get from this, which you might have encountered using an Azure App Service, is that depending on which service level of the app service you use, you might quite quickly run out of the number of ports that you are actually allowed to use outbound. And by using a NAT gateway, you can dramatically upgrade the amount of ports and IP addresses that you can use. So if you ever run out of ports, this might also be a way to get out, or pay more for Azure App Service, or fix your application, because it's almost always a kind of a bug in your application, which might be hard to fix. All right, let's go into the Azure portal and see what it actually looks like. I already created the NOT gateway up front. So it's a pretty simple service actually. It doesn't require a lot of configuration. What you do need to do obviously is give it a public IP address, which will then be used to connect outwards. And you connect your NOT gateway to a particular subnet, and then all traffic coming out of that particular subnet to the public internet will now use this NOT gateway to go out. So let's see if that actually works. Let's try to remember this particular IP address. Now let's go into my UI. Let's pick the right one. Let's go into that admin console that I just talked about. If it actually loads and shows me the button. There we are. Because we want to go to Advanced Tools, and then we click here and go to the Advanced Tool pane. You need to log in again. And this is that admin management pane that we just talked about when we talked about the access restrictions. So this is where you can find your logs and all sorts of stuff. But you can also go to a debug console and actually get a PowerShell console into your Azure App Service. And if we use that and run a bit of PowerShell, then that returns the exact IP address that we just saw on the NOT gateway. So this is now my outgoing IP address for this particular app server. But if we go back to the networking blade, and we scroll down a bit to the outwards traffic section, then this is the list of IP addresses that are normally used for outbound traffic. So you can see that's quite a list. And as I mentioned before, this is not just your application. This is being used by others as well. So that's quite a huge benefit, I would say. All right. That concludes the first part of the architecture that we wanted to build. But then we come back to the question of, okay, now we've been locking down the API in the database. How do I now, as a developer, still get into the database to do a bit of debugging? Or how do I actually do deployments into the Azure App Service? Because when you lock down that admin side, you also lock down deployments over a public address into an Azure App Service. So if you do that, you need to figure out another way to get into the services. One way to do that, as a developer at least, for manual stuff, is to use Azure Bastion. Azure Bastion is a service that you can use through the Azure portal, for example. And that allows you to log into a virtual machine in the Azure cloud using an HTML5 based web client. So you don't need to enable remote desktop protocol. You don't need to enable SSH on a Linux machine. So you don't need to open up those ports to the public internet. But it uses an HTML5 client in the Azure portal, which then connects underwater into your networks, which allows you then to connect into an Azure VM. So that's a nice and secure way to get into a VM instead of doing it over a public remote desktop port. And since a while, there's now also native clients for at least Linux and for Windows to connect into a VM over Bastion, whereas previously you had to go into the Azure portal and do it through your browser. But there's now also native clients to do that, which is a huge upgrade. But that only kind of works for manual stuff where you want to log into a VM and do your things. But what if you just want to use your local development laptop to actually do your development, or want to do deployments from Azure DevOps or GitHub or something? Then you need network access into these resources. One way to do that, at least from your development laptop, is to use a VPN connection. And use a VPN connection to get connected into the Azure cloud and then go on to your resources, like SQL database for us. But the thing is, let's first talk about VPN for a bit, and then talk about DNS, which is the other service that we will then also need. So in the Azure cloud, there's a few VPN options that you could pick from. And VPN connections can be used from on-premise locations into the Azure cloud, but can also be used between Azure regions if you want to have a real secure connection between two Azure regions. So first of all, there's what we call the site-to-site version of VPN, which allows you to connect and offers into the Azure cloud. There's also the multi-site version of it, where you have multiple offices that need to connect in the same region in Azure. Like I said, there's also the VNet to VNet version, where you connect VNets into different Azure regions using a VPN connection. Something that's also mostly used by enterprises is what we call Express Route. That's a private, dedicated connection for you into the Azure cloud from your office location. So that's a highly optimal route into the Azure environment. And then still, when companies use Express Routes, they often still have a VPN connection next to that for backup purposes. So if Express Route might go down, although you mostly choose for multiple connections, but if it does go down, you still have the VPN connection to get into your environment. So you can use them side by side. And last but not least, there's also the point-to-site version that you could go for. So instead of your whole office, it could just be a device connecting into the Azure cloud, like your laptop, your mobile phone, etc., using the VPN gateway in Azure. And for all of these options goes that there's multiple ways to connect into the VPN. So you can be using certificates, Azure AD, Radius, or OpenVPN, just what you need. It does depend a bit on the operating system, which options you actually can use. Not all of these options are available on all devices and all operating systems. All right. There's also obviously a lot of third-party solutions in this area, because the VPN stuff in Azure is nice. It does what it has to do, but there's a lot of offerings in the Azure Marketplace that go far beyond just providing a VPN connection. They do a lot of firewalling in place as well, which might be just what you need. So there's also companies like Cato, which I used to work with, that provide you a lot of more details in what's actually happening in your connection and give you much more power than just the VPN solutions in Azure. But again, depends on what you need. All right, but before we can use VPN, there's one more thing that we need to talk about, and that is DNS. Because if something goes wrong, it's always DNS. And that's the same in Azure, unfortunately. So what happened when we create the private endpoint into that SQL database, you also saw me adding that record to the private DNS zone. But the thing is, by default, that private DNS zone can only be reached from within Azure and not from an on-premise network. So if you would use your VPN connection to connect into the Azure cloud, your local machine would not be able to use that private DNS zone and figure out what's the IP address, the private IP address of that particular database. So there's something you need to do to actually get that to work. And up until, I think, 3 months ago, what you needed to do was you needed to create a virtual machine in Azure, in the Azure cloud, a Linux machine. You needed to install a bit of software on that machine so that machine could now act as a DNS forwarder for you. So that means that you, your local client, could send a DNS request to that machine, and that machine would then go into Azure and figure out what IP address to send back to you. But that would mean that you would have to maintain a virtual machine, do the installation of the software, keep it up to date, keep it patched, etc. You probably need at least 2, because if one goes down, you don't have DNS, you have no connection anymore. So you needed to manage a lot of infrastructure that you actually don't want to manage. So luckily, Microsoft came with what we call the DNS Private Resolver, which does exactly the same thing. It allows you to connect into the DNS Resolver, do DNS resolving, and get the answer that you need for stuff that's in the Azure cloud. So it's a new offering that basically replaces the virtual machines that we talked about. It's quite costly, I must admit, if you want to go for a cheap option, at least from purely infrastructure perspective. Then still the VMs are much cheaper, but that means that you need to manage them, etc., which obviously also cost a bit of money. So this is a nice addition to the solutions in the Azure cloud. Right, let's have a quick look at what this actually looks like in the Azure Cloud. Let's go to a different resource group. And in this resource group, I created a kind of similar setup as in the previous one. I created a database, which has a private endpoint connect to it. And the database has a bit of data. It's registered in private DNS, etc., etc. And it has the private DNS resolver that we talked about, which is hooked up into my network because I've configured an inbound and outbound connection. And I also have a VPN gateway so that I can connect into the Azure cloud from my local machine. And luckily, Azure and Microsoft provide you a nice application to actually connect with your VPN connection into the cloud. You can just download that and distribute that to your users. And what you now see is that it has returned. Let me see if this actually does work. I think it does. What you can see is it returned a few routes. So it now knows that, now my connection now knows if I get an IP address back from DNS that I want to connect to, which falls in these routes, it now knows it needs to send that over the VPN connection instead of to the public internet. And what's important here is that you also see that my VPN connection now gives me a new DNS server. So I'm no longer using the DNS server from my internet provider or the one from Google that you might be using. I'm now using the DNS server in Azure. And this IP address that we see over here is actually the IP address of the DNS resolver. So I'm connecting into that particular service to do DNS resolving. And that should mean that I now should be able to connect into a database and actually query, not pick the error log, actually do a query on a database that lives in the Azure cloud, which I've locked down using a private endpoint. But as you can see, using a VPN connection and using the private DNS resolver, I can still connect into that from on-prem and do my thing. All right, that's what I wanted to show you today and tell you about networking in Azure. I hope you enjoyed it. If you want to know more, there's also a blog on my website that also talks a bit about networking and enabling some of the stuff. At least the first demo that I showed you today is also available there in a blog post, so you can always find it. So thanks for joining me, and have a nice rest of the conference. Bye-bye.
Great, thanks, Erwin. Please join me for a second. Well, you weren't joking with all the demos. There were a lot of demos, which I'm very grateful of, because it's very good to see, because it really, I really need the visualization of how everything connects together. But of course, doing it in the Azure portal is, I think, quite different than how you do it maybe at a client, right? Because I expect you have a totally different way with CI/CD stuff. Can you tell something more about that?
Yeah, obviously. So if we do this for a client, we obviously use infrastructure as code.
Mm-hmm.
I mostly use then either Bicep or Terraform to do the deployments of these kind of things. And we use those tools to do the deployments of the infrastructure and then lock down the resource that we actually can lock down. And one of the things that you also need to think about then is then if you lock down your database or your app servers and you still want to do deployments to them, that means that your Azure DevOps agents or your GitHub Action agents and runners still need access into those as well. So you mostly end up with creating your own custom Azure DevOps agents. There might be containers in the Azure cloud or virtual machines in the Azure cloud, which you can then run in your own network, in your private network, which then are allowed into the service.
Makes sense.
Doing the stuff that I showed today in a portal is quite easy. But you need to do a few additional steps if you want to do it all the way.
Yeah, I get it. Yeah. And are these steps mentioned in the book that you co-author, or?
Some of them are.
All right.
But there's at least a few blog posts on my website that go into the details of creating those Azure DevOps agents and hook them into your network and manage them. Yeah.
Okay. Well, I would definitely advise everyone go get the book first, but then also definitely have a look at the blog, because I think there's a lot of learnings in here which are very valuable for a lot of companies here. So
Yeah.
Thanks a lot, Erwin. Great.
Right. Cool.
Right. We'll now take a moment to prepare the next speaker, Purnima. So we'll see you again in a couple of minutes.